The interesting thing about this specific technology is that the barriers to entry through certification and the regulatory challenges and even customer adoption are very, very high. Because they're so high, there's a bow wave of technology that's just waiting to get adopted into aviation, and we're crossing that chasm, bringing it to aviation. And the neat thing is, Bill Gates talks about the green premium. We actually have the opposite of the green premium. Our customers are finding that using electric aviation in their fleets and in their applications is first and foremost commercially viable. Therefore, they can adopt it in scale. That's a big deal for them. Their operations benefit, as we talked about before, because they now have 3 to 5 handling points reduced to 2 with direct operation point to point. And electric propulsion enables that. And number 3, they get to meet their sustainability goals. As you all know, Amazon has a goal of going net zero by 2040. UPS is on that track as well. There's a number of logistics companies who find it really important to reduce their dent on the environment. In fact, UPS, they're the second largest fuel consumer in the US. So a meaningful dent can only be made when we attack these big buckets, not these niche things. And to attack those big buckets, we have to offer something that's first, commercially viable, second, improves operations, and third, is sustainable. And that sustainability is a really important part of what we do. So that's the story on the batteries. Secondly, those recharging centers are actually built out of second-use containers. Those second-use containers, we have a surplus here in North America because the trade imbalance from Asia right now. Those containers sometimes sit in a port and rot. Sometimes they get sent back to Asia empty, which is expensive shipping for nothing. But we said, hey, let's consume those. They're great containers for this type of work. And to adopt electric aviation or electric vehicles or electric marine, it's not a one and done. We don't all of a sudden drop in the infrastructure day one and it gets used. It's a progressive thing. We have to have a modular substructure that we can deploy to the grid in bite-sized pieces. So there's maybe 10 routes the first year, 100 routes the next year, 2,000 routes the third year, 5,000 routes the fifth year. As we grow those, the energy storage, the recharging infrastructure, and of course the airplanes, which are inherently modular because they're units, has to grow with it. So these reused containers gives us the ability to deploy these things at the right scale, at the right place, and that modularity is very important. So systems thinking is a really important part of how we're able to actually bring this technology to the forefront. So another couple important things about this specific aircraft are the materials that are used and the technologies that are used in it. So for example, to the extent possible, we use composites that are recyclable. One of the great things about automobiles is they're substantially steel. That steel can be recycled. They can be stripped of their polymers, the aluminums can come off, the engine block can come out, and they can recycle the steel. With what we call plastic airplanes that have a polymer composite matrix, and then many cases carbon fiber, it's really difficult to recycle that. So to the extent possible, we use thermoplastic composites that actually can be reground and reused. Thermoplastics can be melted and reused numerous times. Thermoset polymers can't necessarily be recycled in the same way. So you'll see pervasive use of those materials in our aircraft. The second important thing that I think people forget about are the auxiliary fluids that are used in aerospace. Hydraulic fluids, oils, coolants, lubricants. And these things, once they're used in the aircraft, they're taken out, and in many cases they're recycled, in many cases they're not, unfortunately. So going to an aircraft that not only goes from ethylene to polypropylene glycol, that would be a nice step, but we actually take all of that liquid cooling out of the airplane completely. All of these motors are air-cooled. Now that takes a little more investment on the front end in engineering and thermal management and the way we route things, but for the 20-year life of the aircraft, you're not replacing fluids that have chemicals in them at every overhaul or every service interval. The same thing's true with the lubrication throughout the aircraft. Oil lubrication versus grease lubrication. Grease lubrication consumes much less than an oil lubrication that needs to be replaced. So the use of recyclable composite materials, the omission of all liquid cooling in the aircraft, gives us a couple benefits. Obviously there's the environmental one. So for our customers, the service intervals are longer. A longer duration between service intervals means that our customers have greater uptime, which means they need less airplanes. Less airplanes means less materials, less energy, less waste, less parking. All of that reduction in waste makes this an adoptable technology for our customers. And that's, of course, really, really critical for us to deploy these things en masse. Another really important part about the adoption of electric aviation is quenching the fears around range anxiety. When we get out flying an airplane in bad weather and the controller doesn't give us optimal routing and the winds pick up from the wrong direction, they're always from the wrong direction, and we end up in a situation where we don't have as much energy and enough margin to really feel comfortable flying this plane for a whole lot of missions, we're going to reduce the adoption of the technology. So this aircraft is a physically large aircraft, a very large aircraft. It's got 50 feet of wings, and in the belly here, there's 3,000 pounds of batteries. Half the mass of the aircraft is in batteries. And that gives it an exceptional range of 250 nautical miles. That range is not important because people are going 250 nautical miles. That range is really important because when they go 100 nautical miles and the wind picks up, and it's not uncommon to fly here westerly and have a 50-knot wind on the nose, and then to get where you're going and not be able to get the optimal routing into your landing spot. So this surplus of energy allows our customers to say, yeah, we're confident putting people, cargo, organs, tissues on the aircraft and sending it westerly. That's an important philosophy that I think gets forgotten about a lot of times in new technology adoption. Everybody imagines how you may fly an airplane. You've got a range, you've got a mission to go, and everything goes honky-dory according to plan. The wind doesn't change, the icing doesn't start. But in our philosophies, being real operators of airplanes, we realize that we've got to make an aircraft that can meet all of those goals before it gets adopted en masse. So here at Beta Technologies, we're developing an electric aircraft system. It includes the aircraft, the recharging, the training, thoughtfulness and mindfulness about how we go about incorporating technologies to the aircraft such that over the 20-year life of the aircraft, it is sustainable to our customers, it's sustainable to our environment, and we make a meaningful dent in turning the corner of climate change. Presently, aviation is 9% of the CO2 emissions from transportation, and we have solutions in electric cars and electric buses, trucks, marine, and so aviation is growing and growing and growing. And if we at Beta and others don't do anything about this, aviation will be the largest contributor by 2035 to carbon emissions in the sector of transportation. So this is really important work that we're doing, and we're doing it, and I believe, in a thoughtful way that both our customers appreciate and the planet appreciates. Thanks again for having me here at the See.Change Sessions, and I hope together we can turn the corner on climate change.